Good evening, everyone. My name is Esainea Barasa, and I have a master degree in physics. I studied at Technical University Darmstadt in Germany, one of my favorite universities in Germany, and I really love it. So I can, if you are looking for university in Germany, I would recommend Technical University Darmstadt. And I work as a business developer at Randstad German, and I have experience in data science for over 2 years now. And have mainly been focusing on time series analysis, making forecasts using different models, a lot of models. Actually, I've tested every model that's available on the market. And I would love to share my knowledge and my experience in data science with you, especially if you are a student, you are new in data science and you have no idea how data science works and so on. So I would really love to share this knowledge and this experience with you, and everything that I want to do. I want to make it so easy and accessible to everyone. So even if you don't have a computer, even if you don't have a computer, will be possible that will be accessible. What you only need is you need an internet and Gmail account, so you will be able to run all these codes, all this what you're going through. You'll be able to execute them without having even your own computer. You can go to internet cafe and just learn data science. This is technology, and this is what we will need in the future. So actually, it is something very powerful. And my focus will be end-to-end applications, so where we'll be what's actually the life of a data science, what actually a scientist does. So we'll be dealing with get data, clean data, and analyze data and visualize data, and have at the end of the day have a dashboard that you can share with anyone who has no idea in data science. So that is my vision. That's my calling. I would love. So if you like this video, if you like this tutorial, or if you have some wishes, or if some if you have some excitements, or if you have some whatever kind of comments you have, please let me know, and I'll love to hear from you, and and to also learn from you. So but first of all, let me give you an overview of my tutorials so that you get inspired. So let me see, just a moment. Okay, yeah. So in my first tutorial, I will have to give an introduction to data science, where we'll deal a bit about theory and so on. And then I will go deeper with a practical example where I will show you how to get access to the Colab notebook, Jupyter notebook that we'll be using to practice. And at the end of the day, so at the end of the first tutorial, so if you follow along with me, so at the end of the day, you will have some basic background. You know how to get data, how to clean data, and how to represent this data in the form of a dashboard. And that is what will be in first tutorial. So the second tutorial will go much deeper to we will be using, even the first tutorial will be using a model called VCM, vector error correction model. But the first tutorial will be just out of the box. In the second tutorial, I will try to give more introduction to VCM model, how the model works, and I will show you how to automatically hyper tune the model parameter and select the best model from all the available parameter combinations. And we will also go much advanced and then add some exogenous variables like a working day to see how the model performs and so on. So this will be more realistic to the business world, to the business situation and so on. So if you get all this tutorial 1 to tutorial 2 right, and you come along with, so you really have you will have all the skills that you need to make time series analysis. So you'll be really successful. You will be an expert in time series analysis if you just follow this first and the second tutorials and come along with. And then I will go further, and I will introduce to you SkyTime library and all the models available there, and we will test these models. And we'll also look at some statistical models like profit and salary marks and so on. And then tutorial 4, Then here I will introduce you to future engineering. Do you know what future engineering is? So if you don't know what future engineering is, then you have really, yeah. So this will be my target. And then I'll give introduction to deep learning and like LSTM, like long short-term memory and computer neural network and so on. So there are a lot of things to cover, and I will try as much as possible to be very clear and to be very simple that everyone can follow. So yeah, that is what I'm looking forward to. And then we will move forward and have a kind of web scraping. So you know what web scraping is? Have you ever have experience in web scraping? So if you haven't, so then you don't have to miss you. Yeah. You definitely have to watch these tutorials, and then we'll be having like sentiment analysis, and I'll move on and then show you how to develop a web application using Django, and we'll move on and see how we can automate some tasks. And so please, so if you like my tutorials or you have some extra wishes, please let me know. But this is my vision that I would like to, this is the journey that I would like you to come along with me. So even if you are in a 12th grade, or even if you are at high school, or even if you are at university, also if you're interested in some of these topics, or if you have some extra topics about data science that you like to know more about, then please let me know. I would love to share my knowledge and my experience with you wherever you are. So first of all, let's see what's data science. So data science is an interdisciplinary field. It's about process and system that really facilitates us to extract knowledge or insights from data. So the goal here is we have data, and from data we extract insights and knowledge so that we can help us to make decisions based on the knowledge and the insight we have. And data science for its own, it depends a lot on a wide range of disciplines. So in data science, we use computer science, we use information science, we use statistical learning, machine learning, probability models, and artificial intelligence, and so on. And we also use mathematics, operational research, visualization, and so on. So I would like, if really you if you're not so good in mathematics, don't be scary, because you don't have to be an expert in mathematics to be a data scientist. Just a basic knowledge in mathematics and a basic knowledge in computer science, and I would try to make it so simple to everyone so that actually you will come along, even if you don't have a degree in mathematics. You don't have to have an A in mathematics to be data scientist. Yeah, and then we will also the main focus we'll be focusing on is to be predictive analytics. So the predictive analytics is what my focus will be. And then in predictive analytics, we will see that computer science, programming, and all of these things will be part of this. And so, what is predictive analytics? Under predictive analytics, we have descriptive statistics and we have predictive models. Yeah, and descriptive statistics is about when you have a historical data. Well, let's say we have a data for the last 10 years, and this data you can summarize your data in terms of the mean for the last what is the lowest value for the from your data that you have. Let's say you have generated revenue for the last 10 years, and you want to find the worst performance, the worst value that you get from your revenue for the last 10 years. So you can summarize your data and know when was the worst time, when was maybe an outbreak or so on. So you can summarize your data, give the mean, give the max, give the median, and so on. And so you can learn from the past. If you can summarize your data, learn from the past, and somehow understand how the historical data may have influence in the future outcome. And examples of descriptive statistics, I think we'll have a practical example, and I will show you just in the next slide. And examples, you can have reports on company sales, on finance, on operation, on operations, and so on. And under descriptive statistics, how we use some models like clustering and like association rules and a network analysis. So how this model work like clustering, if you have, for example, customers, you have customers, you maybe you call you can call them those customers that maybe they are standard customers who buy every day, and you have customers that maybe they just like buy occasionally and so on. So you can group these customers according to the number of orders they make, or according to the revenue that you make with them and so on. So here there is even a specific model, a specific analysis method that we use. It's called RFM, but we will talk about it maybe in another tutorial. So if you have more interest about RFM, frequency and monetary value analysis, we can have an experiment, we can have a tutorial on that, and I will show you how you can implement such a model. But let's say, what is predictive models? So what is predictive statistics? So in predictive statistics, you predict what will happen in the future. And in a common use case, for example, you have the sales from the last, let's say you have from the last 3 years, and you want to know what will be your sales in the next 5 or 3 months. So you can just analyze based on your historical data and make predictions for the next months. So this will be time series analysis, and you can use classification. For example, if you can classify, if you want like in fraud detection, so you can use classification method, or if you want to classify like your email is either a spam or not a spam. So you anytime you have a new email to receive, the model we will use the model you've already trained to tell you if this email is a spam or not a spam. So you automatically in real time you make prediction if this is spam or not a spam in case of an email and so on. So but why predictive analytics? So in companies we have different departments. So we have, for example, sales and marketing. We have operations. We have finance and HR and other sectors. And for example, in sales and marketing, we can use predictive analytics in churn reduction, so that we don't lose customers every year. So if we can make forecasts and predict which customers gonna leave us, gonna leave our company, so we can make some actions, make campaigns, so that we can retain this customer. And you can also kind of do like a campaign optimization, like lead scoring and customer segmentation. And then under operation, we can use predictive analytics in predictive maintenance and load forecasting and in price optimization and so on. And under fraud and risk you can use, especially in insurance or in company and so on. You can we use predictive analytics in fraud detection and claim analysis and so on. So there's a lot of use cases where we really need predictive analytics. So if you really have a knowledge in predictive analytics, knowledge in data science, these are some of the use cases that you can implement, that you can use in your company, or maybe even be like a self-independent. Maybe you can create your own company and maybe make do all this analysis for other companies, and you can generate revenue out of it. So it's even a business idea, and that is something that we're gonna depend even in the near future. And we have in finance, for example, like financial risk modeling, like cash flow and forecasting and so on. And in our tutorials, especially for the first tutorial and second tutorial, we'll be mainly focusing on on forecast, on time series analysis. So at the end of our tutorials, you will be able to make forecasts. You'll be able to really understand this use case, and even use it for your own use case and so on. So I hope if you have any question, please let me know. And then here we have, for example, examples of descriptive statistics. On my left hand, I have I have a few stocks. Most of them Microsoft, Apple, Boeing, Gold, and so on. And this is the stock price for the standard deviation for the stock price in August 2021. So here you have the standard deviation for the high and close value for August 2021, and here on the right, so we have the mean for the stock price for gold. So you can and this is what you will be having in this tutorial when we'll be dealing with practical will be during our lab session. So this kind of dashboard is what you're gonna have, what you're gonna build, and you will understand more about this, because here you can customize, have any kind of stock that you want. And one thing that I'm also trying to have like a real-time analysis. So in case you are you're investing in stocks, or you are interested in somehow kind of like trading and so on, so this application will help you, because it's actually almost real-time analysis. So you really don't need any extra software. You can really use this kind of application that we're building right now and use it for your use case. And then here the next thing is, here we now as an example of predictive statistics. And on the right, so we have this the stock forecast for a specific stock that we have selected. Here we have selected gold, and we have forecast for the next 10 days, starting from I think was at that 1st of August until the 10th of September 2021. And here we have the confidential interval of 80%. So here this main forecast for the close value, and this is our maximum. So we are 80%, but the accuracy is majorly very good. I think it's over 99% accuracy when I'm right. So we can make forecasts for gold with over 99% accuracy, but we are 80% sure that the price will lie between these ranges. And so when you hover around, this is what you can do in this at the end of this tutorial. You can customize this and do anything you want, and you will have these results. So this is example of predictive model. And but further, we have an overview of predictive models. We have classification, and in classification we use, for example, to predict which customer will buy, or we predict in fraud detection, it's a fraud or not, or which customer will churn next, depending on, that's based on a weekly or monthly or yearly data. And so if we know that which customer will churn, will leave our company, we can make some offers, we can make some actions, make some decisions. So things we use machine learning to know what will happen in the future. And if we know what will happen in the future, if you know it's gonna rain next tomorrow, so you have to take an umbrella along with you. So it's the same if you know what will happen with the probability of 99%, so you can really do something about it, because but under classification we have models that we can use. We have random forest model, for example, we can use it, and a lot of other models. And we have regression, and the regression this is we use when we have metrics, when we have numbers, when we have numerical values. And here, when you have, for example, you have revenue, and you have other things that really cause your revenue, or correlate with your revenue, and so on. So you can make forecasts for your revenue based on certain numerical values that you already know. So if you are dealing with regression and you make forecasts for the next 5 months, you have to know the predictors that you're using. Your revenue will be your Y value, and that is the target value, and then the predictors will be your X values, and so on. And then if you make forecasts for revenue, you have to know the predictors. And this, if you already know what will happen in the future, what you know the revenue, you can do some kind of actions. You can minimize reducing expenditure, and like if you know that you'll be making a loss next week or next month, then you can stop hiring new employees, and so on. And then we have a regression is It is interpolation, and then we have time series analysis. We have forecast and time series analysis. What the difference between time series analysis and regression? Time series analysis, you extrapolation. You sometimes you may have just one value, you just have revenue, and you want to know how will be the revenue in the next 5 months. You don't have predictors, you just have one value. So what you do here is kind of you analyze your signal and find out some cycles, some fluctuations, and some seasonality, dependency, and so on. And but what we're gonna be doing in our tutorials, the model we're gonna be using here will allow us to make time series analysis. Will be kind of multivariate, making forecasts for more than one variable, for more than one value. And then we have some other so we have clustering, we have link analysis, we have association, and so on, but I won't talk much about them. But if you are more interested, let me know. Maybe I can prepare an extra tutorial about these models. So let's move on. And then so our focus will be on time series. Okay, so time series analysis. So how really this works? So you have your historical data for the last 10 years, and when you have this historical data, we ingest this data in our machine learning algorithm and methods, and then this our methods will be able to recognize the most in our data, the dependency in our data, so hidden structures, relationships, and so on. So our algorithm will really learn from this data, recognize the most dependency, and so on. And if we have trained our model, then we will get an optimized results output. This is our predictions as a result after we have learned, trained the model, understood everything, and then we make prediction, and we have the optimized predictions. And how does time series work? Here, for example, we have a cumulative sea level change since 1880 up to 2011, and you see how the actually you have normally time series. You have like you have on your x-axis you have like you have time, and then you have the value, and then you see how the value has been trending the last years. For example, here how the sea level has been trending since 1990, and based on how the trend has been, now you can make forecasts. How will this trend go? You can extrapolate. So you are extrapolating it. How will this trend go on in September, and so on? But you also put in consideration the seasonalities and so on. Yeah, but more about this I think I will be in our third tutorial and so on. The models that we use in time series analysis, we have a bar model called vector error, vector auto-regression model, or we also have the extended one, VCM, vector error correction model. So this is the advanced form of a bar model, and this is what we're gonna be using in our tutorials example, because it allows multivariate time series analysis, so we can make forecasts for more than one variable and so on. The other models like the past model and Prophet, Serimax, auto-Riemann regression, and so on. So if you're interested in some of these models, I have attached a link here. You can go over there and get some tutorials about how these models, or what is time series, and so you will get more information about all this. And but all these other models are univariate models, time series models. They can only make forecasts for one variable, for one value. But here VCM, that's why we're gonna use VCM, because it allows multi-time series forecast. And furthermore, we also have deep learning models, and under deep learning models we have LSTM, it's called long short-term memory, and convolutional neural network. But I won't talk much about these models, but we will see in some of our tutorials. And here I have an example of the LSTM model. You can go deeper and get some more information about LSTM model. So let's see what's the goal, what's my agenda. So the objective of my tutorials will be actually that you really, the first tutorial is actually to know the architecture. And then also, if you really know the architecture, you understand what we're building, what we are doing, what I'm focusing on end-to-end scenario. And then all other use cases will be implementing. You will just have to follow this architecture. So this is the basic, this is the foundation, and I would really love that you really know this. That's what I want you to understand. So if you didn't understand the introduction, but understand this architecture, because this is what we're gonna follow. I want you to at the end of this tutorial that you are able in a position to build end-to-end scenario, and here you're gonna acquire some new skills. I'm very sure that most of you that will be watching this video that you haven't had, because this is my own idea, and the way I do it is actually my own idea, so you haven't had anywhere. So this is what I'm sure you're gonna learn some new skills here. So what we're gonna be doing, we're gonna install Yahoo Finance API, and we're gonna use Yahoo Finance API to download some stocks that will be need historical data. So we're gonna get historical data via API. So if we have gotten our historical data, we will save our data in Google Drive so that we can access this data from anywhere. So that's why I said you don't need to have your own computer. You can use Internet Cafe to access this data. And then we're gonna be, when we have our historical data, we're gonna be saving our data to Google Drive, so that as CSV, so that we can access it anytime we want, in case we don't get and if tomorrow maybe the Yahoo API does not exist anymore, but you still have some historical data of some specific stocks, so because you stored in Google Drive. And then we're gonna do some kind of analysis, statistical analysis. You're gonna calculate the mean standard deviation, and then also write our data back to a Google Drive. And then if you want, you can use any kind of BI tool like Tableau, like SAP Analytics, to perform visualization. But for our case, we want to have it in one notebook. So we're gonna be using Bokeh for data visualization. So after we have done all this, we will clean our data, and then use machine learning algorithm to make forecast predictions to know the stock price for the next 10 days, or we can just pass it the way we want. Then after we have the predictions, we would like to have our end results, our historical data, our descriptive statistics, and also our prediction. We want to have them in one dashboard. And this is what we want to have at the end of the day, and then we can share with our end user. So the end user has no idea from all this process, but what she or he knows is only the dashboard at the end of the day. And then here, so these are some of the skills you're gonna go through. We're gonna process the data, we're gonna clean the data, and then we're gonna do some kind of video engineering, and then we're gonna make forecast using VCM. So, but I think for today, that is enough for today, and tomorrow, for the next tutorial, we'll be getting practical. So I'll be getting more deeper about this. So I hope to see you next time. So God bless, have a good day, bye bye.